All right, group. So this is a very quick screencast that I'm going to throw together right now. And it's to show you, it's sort of backing up a little bit, but not entirely, as we will always be thinking about these concepts. But it's about an electron configuration, and specifically it's electron configurations, how to show them when an atom is in its excited state. Boy, nice writing there, Chang. So imagine you have let's just take sort of this one here. Okay. Um, so typically, you all know that the next sublevel that would be coming up here would be a 4s state. And so if I needed to put another electron here, just a single one, that would complete our ground state electron configuration for, what is this? This is for 19. This is for potassium, if I'm not mistaken. Yeah, potassium. All right, so let's imagine, however, that I energize, let's say this potassium, I throw an electrode into it and I energize the potassium, which would be kind of weird, but pretend you didn't. I picked a better one than that. And all of a sudden, this last electron here that I'm pointing to, this guy right here, imagine if that were suddenly to jump from the 4s orbital or 4s sublevel and jump up to a higher sublevel, one that would be it can only get up to if it had that additional energy. And if I were to do that, it would look exactly like this. It would look the same way, 2p6, 3s2, 3p6. However, if I were to show this now in an excited state, let's say it really jumps up here, I would say, let's just randomly pick 5p1. Now, obviously, I've skipped a whole bunch of stuff right in here and before I could go all the way. I normally would want to settle down into 4s1, but it jumped a whole bunch of orbitals and leapt up to the 5p level. So clearly, this would be an atom in its excited state. Now, you might ask yourself, well, who cares about that? What's the big deal? Well, this is the foundation, if you recall, for the explanation of the spectral lines. Because when electrons jump up to a higher level energy and then drop right back down to their ground state, then they emit a photon of light. And certainly you all know this from, let's see if I can find a picture here. Hold on. All right, so should be familiar to you guys. This is a neon light, and it's caused by the neon gases being excited and the electrons being boosted up to a higher energy level and then immediately dropping down, and having one right next to it also be boosted up. As long as you have electricity flowing through the tube of the neon gas, it'll continuously have electrons thrown into an excited state and then drop back down to a ground state and emit that red light that you're so used to, that red glow. Gee, I hope that did actually go in. I'm not sure if it did. And then also something with which you are, I'm sure, amazingly familiar. Let me add this one in. And this is the same concept. Fireworks are based on the same deal here, where obviously they get the energy from the explosiveness of the charge, and they essentially the heating up of the gases cause the electrons to boost up, drop down, and emit certain specific wavelengths of light. And you see that as the different colors associated with the fireworks. So those are practical purposes when we talk about the excited electrons. And then we all understand now how to show an atom in its excited state. You simply, right there, you add in, let me go ahead and point to this right here, an orbital, and throw your electron into that higher energy level orbital, one that would have to be, in this case, above the 4s level. All right, crew. See ya.